Alright, hello everyone, and welcome to a new offline video. Today we're going to discuss 4 things that we have already covered in week 5 and week 6. So I'm going to recover week 5 and week 6 in this video. Specifically, week 5 we covered these 3 topics: what is a DApp, what is a wallet adapter, and we tried to build a few basic apps using the wallet adapter. In week 6, we tried to go through a token launchpad in React. If you look at the slides, this was week 5, the wallet adapter. This was week 6, the token launchpad in React. I'm going to recover both of these today. We'll understand what exactly is the Solana wallet adapter, what is a DApp, a few basic apps we will try to build. The reason I say these are basic apps is because we won't be diving too much into what does the transaction look like when we try to create these applications. I will come to what this means eventually. But then we will build a slightly more complicated application, specifically the token launchpad in React. This would require us to dig a little bit deeper into what exactly is a transaction. How do you create a transaction to, let's say, create a mint? How do you create a transaction to mint some tokens? So on and so forth. So this would require some extra work. I would put this in the difficult category. I would put all 3 in the medium category. If you understand React, if you don't, then it will be a little hard, which is why React and the context API in React are prerequisites to this specific video. So either wait for week 8 in the web dev cohort or go through both of these from somewhere and then come back to this specific video. Without any further ado, let's get into the very first topic for today. What exactly is a DApp? All right, let's kick things off with what exactly is a decentralized app or a DApp. Have you gone to uniswap.org? If not, let me quickly show you what uniswap.org looks like, which is one of many dApps you might interact with if you are, holding a lot of Ethereum, Solana, some cryptocurrency. You want to swap them from time to time. From time to time, for example, in this wallet, I have 20.8 Ethereum and 938 USDC. From time to time, I like to convert my ETH over to USDC. From time to time, I like to convert USDC over to ETH. The Uniswap DApp, the Uniswap decentralized app, lets me do it. If I select over here that I want to convert, let's say 1 Ethereum over to, let's say, USDC, then it tells me, Harkirat, you have around 10 ETH right now. I will let you convert 1 ETH to 2284 USDC. If I click on swap, click on confirm swap, you will see it pops up my wallet, and my wallet now asks for approval. Notice that the wallet does not automatically listen to Uniswap. Uniswap is just another website. Uniswap can request my wallet to sign a transaction. My private key exists inside my wallet. My wallet now asks me, Harkirat, do you want to convert 1 Ethereum to this USDC? This website is asking me to do it. Are you sure you want to do it? If I click on confirm, then my wallet will send out this transaction that Uniswap created for me. So what does Uniswap do? What does any decentralized app do? It in the end requests your wallet for some approval. It requests your wallet to sign a transaction. What is that transaction? That is what the functionality of the DApp is. For this DApp, this allows you to swap. If I look at, excuse me, if I look at another DApp like OpenSea, which is the largest NFT marketplace. Over here, I can buy and sell NFTs. Now, what are NFTs? Don't worry about. But if I go here, it shows me a bunch of what are called non-fungible tokens. For example, this one called DGods. And if I click on buy now, It asks me which wallet do you want to buy from. I select my Ethereum wallet. And then it pops up again. It pops up first a message for me to sign. And then if I do sign this, eventually it will pop up a message that will deduct 1.6 Ethereum from my wallet and add this specific NFT to my wallet. So that is what a dApp is. OpenSea is a dApp. Uniswap is a dApp. And in the second part of today's video, I repeat, in the second part, sorry about that. In the second part, where we will be creating a token launchpad, this will also be a dApp. This will also be a dApp that we will be creating today. So to recap, what is a dApp? Something like Uniswap. What does Uniswap let you do? It lets you swap tokens. Why is it called a dApp? Because dApp, the word has two parts: decentralized app. D stands for decentralized, app stands for, well, app or application or website. A website where you have some access to your wallet. A website which from time to time would request an approval from your wallet is what is called a decentralized app or a dApp. What does a dApp do? Every dApp does, different things, but in the end, each dApp is requesting the user to sign a transaction using their wallet. Each dApp wants you to sign a transaction that facilitates something. In this case, it facilitates you to convert 1 Ethereum to some USDC. In this case, it facilitates you to buy this specific NFT. But this dApp doesn't have access to your private key that exists in these wallets. That private key is present over here securely. This dApp can request for you to sign a transaction. It can request you to approve a transaction that might let you buy this DGOD for 1.6 ETH. It does not have direct access to your private key, so it cannot deduct your balance directly. It can request the user to sign a transaction using their wallet. What is a wallet? MetaMask is a wallet, Phantom is a wallet. The wallet is the place where you store your private key. These are very well, these are open source. They're very well audited. So you know for a fact, okay, if I keep my private key here, it will remain secure. Versus these websites, God knows if they're audited or not, which is why these websites shouldn't have direct access to your private key. These websites should request the wallet. The wallet can, then ask the end user. For example, when I clicked on this, the wallet asked me, you are on a website called Uniswap. This website is telling me, okay, you want to do something like this. Let's say convert 1 ETH to 1 ETH. Don't worry why this happens. Should I do it? And if you click on confirm, then MetaMask will sign that transaction and send it over to the blockchain. Cool. So a dApp requests the user to sign a transaction using their wallet. And the flow of the dApp looks something like this. First, the user comes on the website. Once the user is on the website, user finalizes what do they want to do. In this case, convert 1 Ethereum to this much USDT. Then the dApp requests approval from the user's wallet. The dApp clearly shows you, okay, hey, are you sure you want to convert 1 Ethereum over to 2297, let's say USDT? And if that is what you want, if you are, if the website is doing something and your wallet is confirming that thing, if the wallet is able to parse that transaction and clearly tell you, okay, this is what you wanted, right? Website to kuch bhi bolegi. Website to can't do anything. The wallet is helping you out here by clearly telling you, okay, this is what the website is trying to do. Are you sure you want to do this? And if that is the case, you click on the confirm button right here. User approves the transaction and the wallet signs it and sends the transaction to the blockchain. Since your wallet contains your private key, whenever the dApp requests the wallet to sign a transaction, if you confirm, then it will sign the transaction, send it over to the blockchain. That is what a decentralized app is. That is what a dApp is. We're done with section 1. Hopefully it's clear. Any website can be called a dApp as long as it requests, your wallets to sign a transaction. Now that transaction can be different for every dApp. Some dApp lets you convert one asset to another. For example, Uniswap. Some dApp lets you buy NFTs. Another dApp will let you lend NFTs. Another dApp will let you stake your, let's say, Solana, things like these. So all of these are usually done via websites. These websites also have some fees. If you are using Uniswap, to swap from one token to another, then of course you will have to pay some fees to the founders of Uniswap and to a few more people. We'll get to what those are when we reach a decentralized exchange. Same for OpenSea. If you try to buy it, there is some money that you have to pay to OpenSea as well. This is how the website over here makes money. They are the central facilitator. Okay, whoever wants to sell has also put it here. Whoever wants to buy also came here. So, since they facilitate this transaction, they also take some fees in every transaction. Cool. That is what a dApp is. Let's get into what is the Solana wallet adapter and why do you need the Solana wallet adapter if you want to create a dApp. Now, of course, this is an Ethereum application and so is this. So the Solana wallet adapter won't work here. The Solana wallet adapter will work for Solana based dApps. If you want to create a dApp like, let's say Orca.so, which is a decentralized exchange on Solana. Just like this is a decentralized exchange on Ethereum, it pops up your MetaMask. This is a decentralized exchange on Solana. If I say I want to sell one Solana, it tells me, hey, you will get this much Orca token. Or if I want USDC, it tells me you will get this much USDT. I can connect my wallet. And then I can again similarly, request the wallet to buy. I don't have enough funds, which is why it's not letting me. But this is just another decentralized app on the Solana blockchain. And to be able to build one of your own, if you want to build something like this yourself, you need to understand the Solana wallet adapter. Let's get into that next. All right, let's start creating our first dApp, our first decentralized app. How can you do that? First, initialize an empty React project, npm create wheat @latest. This would initialize an empty project. I'm going to call it week. This is ideally supposed to be week 5. So I'm calling it week 5 dApp. I'm going to select React as the framework, JavaScript as the language, and open this in Visual Studio Code. If you look at this application, this is an empty React project. If you've done this in the past, the next step is installing all the dependencies of this React project. This React project is nothing but a JavaScript project. It has a package.json which has some dependencies. So you have to run npm install to install those dependencies and npm run dev to start the project locally. And when you start it, you see a very nice, pretty default page, which is something we will now get rid of. We don't want this default page that React gives us. We want to create our own UI. So the next step is going to be going in source/app.jsx, going to the root component. Again, I'm assuming you understand React, so I'm just going to use terms now. This is the top level React component. I'm going to get rid of everything here. I'm just going to have something like this and call it hi there. So that is how I have created my very first well, this isn't a decentralized app. This is a basic React application. If I go back here, I see hi there. You might ask, Harkirat, why is the style so good? Why is hi there in the center of the screen? Because there are some default styles in index.css and app.css. You can get rid of them. You will have an ugly website. You can have them. You will have a slightly prettier website because some styles are overloaded. For example, the button styles are overloaded here. The background color is different, which is why it's a slightly prettier website to look at. Cool. I go to app.jsx and here where we had written hi there, we are now going to create our very first dApp. I repeat, these are the steps that I have followed. I have initialized an empty React project. I have gotten rid of all the contents in app.jsx. I have gotten rid of, I did not get rid of CSS. I want to use the default CSS. You can pick and choose. If you want to remove it, feel free to remove it. The thing I haven't done yet is adding a bunch of dependencies to my code base. I want to now create what? I want to create a dApp. What does a dApp need? It needs a Solana wallet adapter. So I need to bring the Solana wallet adapter into my code base. And as I said, there are many wallet adapters available. There isn't just one on Solana, but the most common one that is used is this Kansas wallet adapter Solana. You'll find this in the slides as well, but let me show it to you here. The wallet adapter repository that we are looking at, you don't have to go through its code. It's good if you do, but this is, a Solana wallet adapter. They also have a demo, and if you open the demo, they will clearly show you, okay, hey, we give you buttons like this. We give you buttons that you can use to connect to wallets like these. If I click on this, this specific application is now connected to my Phantom wallet. If I want, I can sign a transaction. If I want, I can sign a message. We'll come to what this means. If I want, I can request airdrop. They already have a demo that does it. We want to create something similar. We want to understand, okay, given this wallet adapter, given this red thingy over here, their code is already something we are going to use. How can we write our own code? What own code of ours should we write that will use this wallet adapter under the hood? That is what we're going to do next. We're going to first bring this to our code base. How can you do that? How can you bring the Solana wallet adapter to your code base? If you go through the docs, TypeScript docs for Solana apps, there you go. It will tell you, here first to bring these dependencies to your code base. Bring the Solana wallet adapter base repository, the Solana wallet adapter React dependency, the Solana wallet adapter React UI dependency, Solana wallet adapter wallets dependency. Bring all of these dependencies to your code base. That is step one. So with the existing set of dependencies that I had in package.json, yahan pe I already had React and React DOM. What other dependencies am I adding? The other dependencies I'm adding are at Solana/wallet adapter base, at Solana/wallet adapter React, and a bunch of other dependencies. Let's run this command, and when it runs and it succeeds eventually, we are now ready to use this library. This command will just bring this library to my code base. I now need to use the things that this library provides me to create my own decentralized app. What is the first decentralized app we are creating? The first decentralized app was requesting airdrop. We want to create something called a faucet, a website that looks like this, soulfaucet.com. This website lets you put in a public key. It lets you put in a Solana address and lets you airdrop one Solana on DevNet or testnet. Harkirat, what is DevNet and testnet? If you remember, these are the testing environments of Solana. If I go to my Phantom wallet here, I am currently connected to mainnet. I currently have 13 USDC in actuality. But if I want, I can click on this profile icon, go to settings, click on this active networks button, click on, no, that is not it. Click on developer settings and turn on testnet mode. Now I can see here my Solana should be connected to Solana DevNet. I want to connect to their Dev blockchain, jahan pe you can request airdrops. You can ask, send me some Solana for testing. Right now, I have 0.97 Solana in testnet mode in my DevNet Solana. I already have 0.97 Solana here. And if I want, I can request more Solana. If I select the Solana wallet here and copy it, paste it over here and click on DevNet, it will send me one Sol of airdrop. It is basically sending me one Solana. As you can see, it became 1.97. It was only 0.97 before. But this Solana doesn't mean anything. This is on the DevNet blockchain. This is on a test blockchain for developers to just try things out. If I go back to mainnet, if I click on this settings, developer settings, and turn off testnet mode, then how much money do I have? I only have 13 USDC and some very little Sol. But in my test environment, in the Solana dev environment, developer settings, turn it on. In my test environment, I have a lot of Sol. I have 1.97 testnet Sol, DevNet Sol, doesn't mean anything. This is the website that we are creating, a place where there is an input box. Actually, this is not exactly what we are creating. You might think this is a dApp, but is this a dApp? Debatable. This doesn't connect to my wallet. it doesn't have a connect wallet button. If you remember Uniswap, when I went to uniswap.org, the first thing it asks you is connect your wallet. Mine is already connected over here. Let me disconnect it. There you go. The first thing it'll ask you is, hey, please create an account. Please log in. And when you click on login, it'll ask you, okay, which wallet do you want to connect to? You have MetaMask, you have Phantom, you have Backpack. Which one of these wallets do you want Uniswap to request from? And you select, let's say, MetaMask. And then MetaMask asks you, okay, hey, are you sure you want to connect this specific wallet? You can select yes. You select yes, confirm. And now you're connected to this Uniswap website. Does this website let you do the same thing? It doesn't. It doesn't use any of the wallet constructs. It doesn't let you connect to your wallet and, automatically send Solana over there. It asks you for the public address. But since we want to learn about the Solana wallet adapter, we want to learn about doing things using the Solana wallet adapter, our website is going to be slightly different. We are going to have a connect button on the website. I repeat, we are going to have a very similar to the connect button that was present over here. After I log out, there is a login button here, which lets me select a wallet. Similar button we want to create on our website. We will have a button that says connect. And when you click on this button, you select which one of these wallets do you need. Do you want to connect to Phantom? Do you want to connect to MetaMask? Do you want to connect to Backpack? A pop-up comes, you select your wallet. And once you have selected your wallet, we already know your public key. I repeat, once you select your wallet, we already know your public key. We maybe only ask for how much Solana do you want to send? Let's say 1 Sol. We only ask how much Solana do you want to send? And then we let you send that much Solana. This is how we're going to build our dApp today. A website where when you come for the first time, I repeat, when you come for the first time, you only see a connect button. But once you connect your wallet, once you connect one of these 3 wallets, whichever one it might be, then you can, we reach the screen. You can ask the user how much Solana they want. You can send them that much Solana. Let's see how we can do that. The first thing we have to do to be able to even see a connect button is use the Solana wallet adapter library. This library exports a few things. I repeat, our app.jsx is very plain right now. If you look at app.jsx, it's a simple app component that returns a div, which also doesn't have anything. We want a button to appear over here that says connect wallet. And we want, when the user clicks on this button, they can select the wallet that they want to go to. To do that, you can use the exports that come from the wallet adapter library. We will do this very often when we reach React. We will use a lot of external libraries. Today, we are using the Solana wallet adapter library. And these are the imports that we're going to add. This will import a bunch of components. We will see them very soon. This will import all the styles required. So make sure you also import the styles at the top of your application. Now comes the meat of the code. Now, this is a slightly complicated code. Let me trim this down a little bit and make your life a little bit easier. These are the 3 providers. Harkirat, what is a provider? Something we will discuss in the context API in React eventually. These are the 3 providers inside which you need to wrap your application. Your application, whatever it might be, right now it's just this much, needs to be wrapped inside 3 providers. What do I mean when I say needs to be wrapped? I mean, if you have done the context API, then you know what this wrapping means. The context API, the thing that I'm doing over here, the connection provider that I have over here is going to provide something in the internal components, whatever these components are. The wallet provider is going to provide something. The wallet modal provider is also going to provide something. So these 3 are called context providers and they provide you some variables. We will see what those variables are very soon. So what have I done? Imported a few things at the top, replaced this endpoint with, let's say we want to connect to DevNet right now. So devnet.solana.com. I think that is right. I could be wrong. I think that's the right URL for DevNet. That is wrong. What is the Solana DevNet URL? Solana DevNet URL. The default URL is this, api.devnet.solana.com. So it is. This is what we want to connect to right now. Eventually we will replace this with mainnet as well when we have real Solana. But right now we only have DevNet Solana, and hence we're going to stick to DevNet. And the second provider over here has something called wallets, which you can pass in as an empty array. You might ask, Harkirat, you are passing wallets as an empty array. Why? The user to eventually will have multiple wallets. I repeat, we were saying when you click on the connect button, you need to select one of these three wallets. How are you passing nothing over here? Shouldn't you pass something like MetaMask and Phantom over here? And the answer is no. You have to pass wallets in here that don't follow the wallet standard. I repeat, if you create some special wallet of yours tomorrow, which does not follow a specific standard, in that case, you need to pass in that wallet explicitly. But all of these wallets follow a specific standard, so they are auto detected. If you remember over here, it says MetaMask recent, Phantom detected, Backpack detected. The wallet adapter can detect that you have these three wallets available right now. So you can pass in an empty array over here. You don't have to explicitly give the various wallets. Now comes the most interesting bit. What is the first screen that we want to create? A screen which has a connect button. The user should be able to connect their wallet so we can get their public key. We can get what wallet is this and what public key is present of that wallet. For that, again, this library, the add Solana / wallet adapter library, provides you with two components, a wallet multi button and a wallet disconnect button. The wallet multi button component, this wallet multi button, if you go to localhost 5173, after I rerun the application, after I run npm run dev and rerun the application, now if you look at it, the application has a select wallet button at the bottom. If you look at this button, it automatically detects that you have Phantom and you have Backpack Harkirat. Harkirat, it doesn't detect MetaMask. It doesn't detect MetaMask because MetaMask is not a Solana wallet. It is a Ethereum wallet. But as you can see, it is able to detect the other two. So the one line of code that I brought to my code base, this specific wallet multi component, now gives me all the functionality to connect to these wallets. I don't have to write that logic myself. That is what a Solana wallet adapter provides you. It gives you this very nice button. You click on this button, you connect your wallet. It asks the right things. Hey, are you sure you want to connect account 16 to this website? You click on the connect button. And now, as you can see, my website has the public key over here. My website was able to detect, this is the person. They have connected their wallet here. Connected their wallet means now this website can ask for approvals to sign transactions. If this was Uniswap, you would have a swap button over here. The user clicks on the swap button, pop-up comes. What are we building? We are building a faucet. So after the user connects, I repeat, what were we supposed to do after the user connects? We are supposed to show them an input box and show them a send button. That is what we're going to do next. Given the user can now, where did it go? Connect their wallet. Now we need to show them an input box and a submit button. When they click on the submit button, they should receive Solana in their DevNet wallet. Right now I have 1.97 Solana. Let's see, now that I'm connected, if I put an input box here and make the user click on a button, how can I make this balance go up to 2.97? Let's see that next. All right. We have the button. It does what it's supposed to do. What do we want to do next? Number one, let's put this in the center of the screen. Looks a little weird. Hidden here on the left. Style. I think that should do it. What did I do? I made its width 100 VW. That means the complete width of the current window. Display, flex, justify, content center. That will centrally align this guy. What do I have to do next? I'm going to create a fresh component called request airdrop. I repeat, I'm going to create a fresh component. Let me disable AI here really quickly. Disable super maven for JavaScript, open this on the left and create a new file called request_airdrop.jsx. From here, I'm going to export a function called request_airdrop, which will return what? Number one, it's supposed to return an input box, type equal to text, placeholder equal to amount. Number two, it is going to export a button called request airdrop. And when you click on this button, I repeat, when you click on this button, a request airdrop function is called. I repeat, I'm also creating a function inside here called request airdrop. And here, right now I will alert something called, a simple message called hi there. But eventually I want this function to actually send a request to the blockchain, actually request one Solana of airdrop for, this specific user. So this component that I have defined in request airdrop.jsx, I'm going to now use over here. I have already used it. I haven't yet imported it, which is why, let me delete the last letter, put P over here, and the auto import in VS Code helps me out. If I select this, I have imported the request airdrop function from /request airdrop. So from this specific component right here, I export a function called request airdrop. I import it over here, and then I call it, or whatever, render it on the screen. Now, if I go back to the website, it looks like this. You can make it prettier, but the user comes, connects their wallet, puts an amount, clicks on request airdrop, which right now alerts something on the screen. But what do we want it to do? We want it to request an airdrop. We want it to send the user, let's say, 1 Sol. Thankfully, if you remember from the initial classes, there is a request airdrop function that comes exported from @Solana. Well, that might not work actually. Let's not go that route. There is another way to do it. Let's look at the other way. The app.jsx, if you remember, we had wrapped our application around a connection provider, a wallet provider, and a wallet modal provider. If you remember, I said that these are providing you something. They will provide something that you can use in your future components that are wrapped around these providers. These providers wrap a component, specifically in this case, the request airdrop component. And inside this component, right now I am alerting something on the screen. Whenever the user clicks on this button right here, what do I want to do? I want to use something that these guys provide. Number one, I want to use the current public key. I want, क्या public key क्या है? I want this 5JIL public key, let's say rendered on the screen. I want the user to see it over here. Here, the user already sees it over here. Yes, I want the full public key printed on the screen. So for that, I can use something called the wallet that is provided by @Solana/wallet adapter React. This provides me something that I am using over here. And now this wallet object that I have provides you something called the public key, which is the public key of the current user. If I refresh, it throws an error because I need to convert this into a string, most probably because wallet.public key is an object of a class. If I hover over this, you will see it tells you okay, public key is of type public key, which basically means it is not a string, but it is a class ka object, which is why I call this method on it that actually gives me the thing in the string format. Now, if I refresh, I still see an error. Let's try to see what that is. Cannot read property of null. Put a question mark over here. Here, what question mark? Such hard syntax you are throwing at my face. Sure, do this. This is all going to sound very difficult to you if you don't know, optional chaining in React, which is what I did over here. And why is this becoming null? Let me not complicate things for you too much. Just put a small check here. That will also confuse you. I'm trying to make it very easy for you to understand. Let's just put a question mark here. Harkiyat, what does the question mark do? it basically says, "Kya, if this exists, then call this function on it. But if this doesn't exist, then don't call this function on it." That is what the question mark dot does. Question mark dot says, "Kya, if this exists, then we are good to go. Then you can call 2 base 58. If this doesn't exist, then the question mark dot will do what? Then the question mark dot will, not throw an error, which is why now if I refresh this, you see wallet, input box, request airdrop, and text over here. Cool. It just looks very bad. So what I'm going to do now is go back here and move this out of the request airdrop thingy. Have it be its own thing. It's now left aligned. So it can be over here. But let me just put a BR tag here. I think that should do it. That doesn't do it either. Put it over here and then maybe let it be its own thing. There you go. Something like this. Looks decent. Yeah, that's why I hate the default styles it provides you, because it overrides a few things that is causing this to be left aligned, this to be left aligned. Why this whole big thing is here. We can fix it eventually. We anyways will eventually be removing this, which is why it will automatically get centrally aligned. But feel free to fix the styles on your side, make it look pretty, all that jazz. All right, we have this. I can see the public key. What did we learn in this section? Okay, there is some use wallet function that I can use. At Solana/wallet adapter react provides me a use wallet function. When I call this use wallet function, it returns me something which has a public key. It returns me an object which has an attribute called public key, which when I call 2 base 58 on, Harkirat, where does this come from? Go to the initial videos. Solana public addresses are in base 58. So this public key class that I showed you over here actually has a function called 2 base 58 that you can call. That will pretty much convert it into, let's say a string that is readable. So that is what is happening over here. And that is how this gets rendered. Now, what I'm going to do is, here, whenever this request airdrop function gets called, I actually want to request the user to get some airdrop, right? I actually want कि ये जो public key है, this public key should receive some money. Const public key equal to this thing. I need to request airdrop on this public key, which is the user's connected public key. What is the difference between our website and Solfaucet, the thing that we saw? This website expects you to put an address. Our website automatically detects the address. It automatically knows that this specific person is who? This specific person is, let's say 5GIL, this public key. So that is the difference between Solfaucet and our website. Here also you have to put an amount. In our website also you have to put an amount. Here also there is a button that says, send it to DevNet or testnet. In our case, we only request airdrop to DevNet, but we auto detect the public key. These guys expect you to manually put the public key. If I click on request airdrop, what should happen? What are the two providers here in app.jsx? Wallet provider. Whatever this guy provides, I am using over here. This use wallet function only works because I have provided the wallet from here. We will learn about this eventually when we learn the context API. And similarly, the connection provider. What is the connection? Connection to the RPC. This connection provider provides you a connection object. Const connection equal to use connection. It provides you a connection object on which you can call request airdrop with the right public key. This connection object you might have seen in the past. In the past, we have done this. Import connection from @solana/web3.js. Const connection equal to new connection. API.devnet.solana.com. You get the idea. This is one way to create a connection to the Solana blockchain And then on this connection object also you can call request airdrop. If you hover over this, it will show you, okay, there is a request airdrop function that exists on this connection object. But I am not recreating it. I am simply using the connection object that we have created once in app.jsx. Either is fine. That will also work. But if you have already created a connection to the Solana blockchain once over here, why create it again? That is why this connection provider creates a connection to the RPC, this specific RPC. And over here, what are we doing? We are calling connection.request airdrop, which will request the Solana blockchain to send, whatever. Oh, I probably have to pass in the amount here as well. What does this return? It needs to be something like this. Const connection equal to use connection. And here we can call connection.request airdrop, which most probably expects two arguments. It expects two arguments. The first argument being where do you want to send the money? Second argument being how much money do you want to send? So the first argument, if you notice the type of the first argument, what is it? It is public key. It is not a string. It does not expect a string as an input. It expects, this public key object. And hence, I shouldn't convert it into a string over here. I simply have public key that I pass in over here. And what is the second argument? How much money do you want to send? Do you want to send them 1 Solana? Do you want to send them 2 Solana? You want to send them however much amount the user put over here, that much Solana. So what should the amount be that I want to send? The amount would be document.getElementById. And let me give this input box an ID of, let's say, amount. I want to get this input box, the inner value inside it. And then when I call the request airdrop function, I'm going to send amount into what? Into the total number of lampots per sol. What does this function expect as inputs? The request airdrop function expects where do you want to send the money and how much lampots you want to send, not how much Solana you want to send. If the user wants to send 0.01 sol, we don't say I want to send 0.01 sol. We say you want to send 0.01 into 10 raised per 9, which is the total amount of Solana in lampots. What is 1 sol? 1 sol is 10 raised per 9 lampots. So whatever input the user gives us, which is this amount, we multiply it by 10 raised per 9 or this variable that is exported from @solana/web3.js. If you now look at the final outcome, if I now go to the browser and go to localhost:3000 and start this application locally, localhost:5173. My wallet is already connected over here. Let me open the wallet and show it to you. This is the wallet. How much Solana does it have currently? On DevNet, it has 1.97 Solana. Let me put an amount over here, 0.5. Before I click on the request airdrop function, let me open the network tab so we can see the outgoing requests. Let me open it on the right here. This is the network tab. If I click on the request airdrop function, what is this text over here? I probably have some text. Let me remove that. If I click on the request airdrop function now, what would happen? Control would reach here. I have the public key. I have the amount that the user wants to send, and I call connection.request airdrop, which should hopefully request for 0.5 sol of airdrop. If I click on it, you can see a request go out to api.devnets.solana.com. If I open it, you will see the method that we are calling is request airdrop. You will see the arguments that we are calling it with is this and 0.5 into 10 is per 9. So under the hood, this is just an HTTP call only. You are still interacting with an RPC server. You are still calling a method called request airdrop, and these are the arguments that you're sending. Only thing is the wallet address we got directly from the user rather than asking the user to put it in an input box. If I now open this, as you can see, the amount has increased by 0.5 Sol. So have we created a dApp? Yes. What does this dApp do? It lets you request for airdrop. What should you name this? You can name this a faucet. What is the use case of requesting airdrop? Whenever there is a developer who's testing, they will test things in DevNet, and hence they need some DevNet Solana, which they can request now by coming to your website. That is the goal of this very first thing that we have built. If you remember, we were supposed to build 4 things. This is the first one, which is requesting airdrop. My pencil isn't working suddenly. This is the first one, requesting airdrop. And the one that we're going to learn about next is going to be how can you show the user a balance? How much Solana do they have? Currently, how much Solana do I have? I have 2.475 Solana. I want to show the user their balance here. Okay, you currently have X Solana. We have already done the more difficult thing, I would say. We have already sent a transaction that requests airdrop for the user. What do we want to do next? We want to see, given this public key, how much money does this person have? How much Solana does this person have? This is actually much easier to do than requesting airdrop. Can you think of a way to do this? We have discussed this a little bit in the past. How can you show the user their balance over here? When we created the wallet, if you remember, when we created the web-based wallet, we shared a little bit how can you get the account information and show the user their balance. Can you add that here? I'm going to discuss that in the next section, but try to add that yourself. Again, the code is already present here. That's 100x devs cohort 3/week 5 web3 source/airdrop.jsx is what we just wrote. And what are we showing next? What are we going to do the next? Show Solana balance. Can you try it yourself? If not, can you read through this code? If not, you should come to the video. In the next section, I'm going to cover this. All right. Request airdrop is done. Next up, I'm going to create a new component file called showbalance.jsx, which, as the name suggests, is going to show the user their balance, how much money they have. How can we create this? If you remember, we used Postman in the past to send RPC requests. Let me show this to you really quickly. If you remember, we used Postman in the past to send RPC requests to the Solana blockchain, and the common method over there that we use was get account info. This get account info function would return you how much Lamports the user has or this account has, along with a bunch of other things. What was the function we called? Get account info. Are we trying to send something over the RPC connection? Yes, we are. We are trying to send some data over the RPC connection, fetching back the current account info. So, can I say this is right? Okay, the connection object that we saw initially in the last section, we saw this connection object. Maybe this connection object exposes a function we can use. This connection object exposed a request airdrop function. We saw that in the last slide. And we saw, under the hood, this would send a RPC request with the request airdrop as the method. And similarly, maybe it has a get account info function. And even better, it has a get balance function, which I would think we can check very soon. But I think under the hood, this would just send a get account info request and just parse the response to get back the number of Lamports the user has. So we can simply call connection.getBalance over here. Let me put this inside an async function because get me user balance, because this connection.getBalance call will be an async call. It will not happen immediately. It will send a request over the wire. It will send a request over the network. It will hit an RPC URL, get back the response. And hence we need to await on this call before, let's say, setting it over here. Span ID equal to balance. Let's say I will just get the balance and do a document dot get element by ID balance dot inner HTML equal to balance. I would hope that this balance is returned in. It is a number. I'm not sure if it is in Lampports or otherwise. If it is in Lampports, we will have to divide it. But if not, then this is fine. We can show this is the user's balance. What is the one thing that I'm missing? Can you guess? I am not passing in the public key as an input. I also need to send whose balance do you want. So if you remember, we did a const wallet equal to use wallet in the last slide. This would give me the details of the currently connected wallet. And given I have this, can I do something like this? Wallet.public key. If you remember, wallet.public key is what stores the current user's public key, or the current connected wallet's public key. So if I call connection.getBalance, hopefully that is good enough. I have defined this function over here. Let me call this function. For the people who are already well versed with React, you should know I should ideally wrap this inside a use effect with the public key or the wallet as the dependency. But if you did not understand what I just did here, this is also fine. A simple function call is also fine. But if you know React, if you know hooks, then what I did before this is actually the right way to implement it, even though it's fine if you don't understand it. This will also work. What will happen when this component gets rendered? I will do a call over here, which will get the user's balance and update this HTML tag with that user balance in this line of code. This line of code would update this section to, let's say store 2.57, which is the amount of SOL that I have currently in my wallet. So let's see if that works. Let me save this. Let me take this show balance component, go back to app.jsx, and I'm going to comment the request airdrop component for now and put the show balance component over here. This show balance component is what now has our code to show the user their balance. Let's see if it worked. If I go back, let me see if this is running. This is running. Let me go back to my Chrome and run this. And as you can see, it shows balance, a very big number, SOL. So what am I missing? I need to divide this balance by number of Lampports per SOL. I need to divide the balance. This balance is not in SOL amount. This balance is in Lamport amount. So I need to divide it by 10s/9. If I see this now, it tells me whatever wallet you have connected, its SOL balance is 2.47. If I change my wallet to, let's say, this one, this has 0 SOL. Let me find one which has some DevNet SOL. This one has 1 SOL. Let me refresh. Let me disconnect. As you can see, it's already connected. So this, what is it showing me now? It is showing me 1 SOL over here. It is not showing me a different balance, or the balance of the old wallet. So that is the second assignment for today. The second assignment being, if you remember, show the user their Solana balance. These are the two sort of easy ones. Now we're going to get to a slightly difficult one, which is signing a transaction sending that transaction to the blockchain. Specifically, the transaction we'll be looking at would be, how can you send someone else Solana? How can this decentralized app become more like, a sender app, a netbanking.hdfcbank.com app, where you can, paste someone's address and send over Solana to them. That is what we're going to understand next. All right. Amongst the 4 assignments for today, we've been able to do 1, request airdrop, 2, show Solana balance. These were the easy ones. Now let's go to slightly harder one. Again, not too difficult. If you understood the first 2, this one should be fairly easy to digest. Let me copy this over into my local project and create a fresh component over here called send tokens.jsx. What am I doing over here in this send tokens component? Number 1, I get the wallet and the connection object, similar to how we've been doing it until now. Ignore this send token functions. This is where the meat of our logic is. Then I render 3 input boxes. 1 input box, where do you want to send the money? Second input box, how much money do you want to send to that wallet? And then a button. When you click on this button, the send token function gets called. Now, before we look at it, let's see whether or not this works. Does it really work as expected? Let me go back to app.jsx, and over here, let me put in the send tokens component. What am I doing? I'm rendering the send tokens component, which the HTML looks fairly simple. It has two input boxes and a button. But the difficult bit is here in the send tokens function. Let's see it in action. If I go to localhost :5173, I am connected to my wallet. It shows me two things. Where do you want to send the Solana? How much Solana do you want to send? So it is very similar to what happens here. If I go to my Phantom wallet, I see a send section where I can send, okay, I want to send Solana with, let's say, this much amount to, let's say, whatever address I paste over here. When I click on next, click on send, 0.01 Sol goes into that recipient's account. You can do it over here, or we are building a dApp that lets the user do the same thing. So the user can come over here and let me select, a random wallet. Let me select the wallet right above it and copy its public key. And I'm going to say, hey, I want to send this wallet 0.5 Sol. How much Solana do I have right now? I have 1 Sol. I want to transfer 0.5 Sol from here to the wallet right above. Or you can get a friend's wallet address as well. That is also fine. And before I click on send, let me click on inspect, open the network tab, and keep it open on the right and click on send. Let's look at the send function. What did it do? Again, it interacted with api.devnet.solana.com. But this time, this was get latest block hash preview. That payload looks wrong. Let's try that one more time. That did not work as expected. Ideally, Phantom should have popped up and asked me for approval. But when I click on send, there you go. Phantom popped up. Maybe it got hidden behind and I didn't see it. Phantom pops up and clearly shows, Kiar, are you sure you want to send 0.5 Solana? I repeat, this is very important. When I click on the send button over here, that was from before, makes sense. When I click on send over here, it asks Phantom, or it requests Phantom, my website requests Phantom, okay, hey, 0.2 Sol. The user now, I need to approve or deny this transaction. Okay, this dApp is wanting to subtract 0.2 Sol from your account. Do you want to do this? And if I confirm, only then will the transaction go out. I repeat. If you look at the wallet now, it has 0.8 Sol or 0.799 Sol. Some went into gas, 0.2 Sol went to the wallet right above. So since we are creating a dApp, and this dApp could be anything, in the future it might be Uniswap. Since we are creating a dApp, this dApp can only request your wallet to sign a transaction. It cannot sign the transaction on behalf of the wallet. This wallet never shares the private key with this website, which is why this website is, if the user comes on this website, it is fine. It can request the Phantom for approval on certain transactions. For example, debiting 0.2 Sol. Phantom will show the user clearly, okay, this is the transaction that this website wants to do. Are you sure you want to approve this transaction? And if you do approve this transaction, then the money will go. If you deny this transaction, then of course the money won't get debited. Then it is almost like the dApp wanted to do something, but the user denied that. Yeah, I don't want it. I don't want 0.2 Sol to be debited from my account. But if the user in actuality wants to send money, then they will click on the send button. Pop-up comes up. User will click on confirm. And then, the money will actually go from this wallet to whatever wallet the other one was. So if I look at the transactions over here, if I go to explorer.solana.com, paste the public key over here. If I look at go to DevNet, and now if I look at the transactions over here, you will see a few seconds ago there was a transaction. If I look at the transaction signature, it shows me that I called the system program.transfer function. I called system program.transfer. Here's what is system program. Go to week 7 video where we have discussed this in detail. And I call the transfer function on it, which transferred money from here to here. How much money? 0.2 Sol. So we have sort of created a functioning dApp now, a real dApp that requests user for approval. Of course, it does something very rudimentary. It only lets you send money, which a wallet anyways lets you do. But at least we understand that a dApp can now request a wallet to send money. You have been able to create a website which actually pops up Phantom. If Backpack was connected, it would have been able to pop up Backpack. Let's try that. Let me disconnect. Let me select Backpack as my wallet. Let me click on send. As you can see, Backpack popped up. It asked me for my password over here. After I logged in, it tells me the transaction was reverted, which probably happened because this is not connected to mainnet but devnet. Yeah, this is connected to mainnet. This is devnet, which is why this cannot ask Backpack for approval right now. But if I change the network over here by going to Solana, RPC connection, custom, api.devnet.solana.com, it tells me that there is a custom RPC URL you are using, Harkirat, the devnet URL. In devnet, I have 319 Solana, or 2.47 Solana, which is equivalent to $319. If I now select a random address and some amount and click on send, Backpack pops up, and it is not able to do devnet transactions for some reason. Keeps saying transaction was reverted. There you go. Their transaction simulation basically is messed up right now. Let me try to send 2 Sol and see if it works. Yeah, it is working. It is able to send transactions. Only this transaction simulation is a little messed up. It is not showing you clearly. Okay, you are trying to send my 2 Sol. It is telling you, hey, the transaction was reverted, transaction hui nahi, ya hogi nahi. But in actuality, the transaction is happening. As you can see, it is clearly showing you that the transaction is happening. Backpack on devnet is not showing you the right transaction simulation. As you can see, amount went down. If I try to send 0.1 Sol, ideally this pop-up should show me, hey, you are trying to sell 0.1 Sol. Are you sure you want to do it? And I can approve and deny it. It is showing me something else, which means their transaction simulation is broken. You can debug why that is and, file for a PR. Backpack is still sort of source available. So if you want, there are a few pull requests here. So yeah, decide, don't spam, but if you can set it up locally and figure out why transaction simulation is failing here, it's a good PR to fix things. All right, cool. With that, we're done with, I haven't yet explained the code, the most important bit. What does the send tokens function do? Can you guess? Here I'm going to introduce something new, which is creating a transaction object. Until now, we haven't really created a transaction. We haven't really asked the user to sign a transaction. But now we want the user to debit some money from their account. We want, however amount is written over here, whatever amount is written over here, and whatever the public key is that the user wants to send the money to, get both of these values here and create a transaction which has a single instruction. If you remember, there are 2 things, a transaction and an instruction. A single transaction can have multiple instructions. For example, here I can write here, I want to send 0.1 Sol to one person, and then maybe another request over here to send whatever, let's say 5 Sol to another person. So a different person, let's say here I put some other random public key. So a single transaction can have multiple instructions. I only have a single instruction over here. I'm going to restrict myself to, just do one thing. But if you want, you can shove various instructions here. In fact, if you remember the transaction simulation that we saw, the transaction, signature that we saw, the transaction that we saw on Explorer, you saw that this had 3 instructions. When I was a while back trying to inspect one of the transactions, this was one of the instructions that I sent, transfer instructions. But Phantom will add these compute budget program instructions by default. Since, when I click on this button, Phantom pops up or Backpack pops up. Phantom and Backpack add these extra instructions. I think Backpack doesn't. So if I actually look at the Backpack wallet and copy this wallet address and go to, Explorer and try to look at this one that Backpack signed, then here you will notice the recent transaction. It also had a single compute budget program instruction. What is this instruction? We'll get to when we reach gas. So all wallets sort of add these compute budget program instructions. And this is the real instruction that we wanted to send. If you look at the code, that ran this transaction. In the code, I had a single instruction inside the transaction, but Backpack added another instruction to make sure my transaction actually reaches the blockchain. This extra instruction is added by wallets to make sure your instruction reaches the blockchain. It does some gas optimizations. We'll get to this soon enough. So that is what this extra instruction does. This is the one we added by default, which was system program.transfer. Do we understand the system program? We discussed it in week 7. System program.transfer would let you transfer money from this public key to this public key, where this to variable comes from whatever the user has put in this input box. Whatever the user has put in this input box, that is what we get into the to variable. And the input that it expects, if I hover over this transfer function, it expects, or if I hover over here, you will see it expects it to be a public key. It does not expect a string. I cannot simply write 2 over here. It will fail because 2 is a string, but new public key of 2 is an object of this public key class, which is what this to pub key needs to be. And lampports is how much lampports you want to send in this transaction. Finally, we call wallet.send transaction that actually sends a transaction on the blockchain. And then you alert the user, hey, this much amount has been sent. So yeah, this is what pops up the Phantom wallet. If I comment this line out, wallet.send transaction, this wallet object dot send transaction. So if I refresh now and put whatever over here, doesn't matter. If I click on send, nothing will happen because I have not called a wallet.send transaction. These two are just creating the transaction object. This is actually requesting the wallet to pop up and show something over here. So if I now put let's say where did it go? A real value over here. If I put a real value over here and a real value over here, and let's say this is commented, then if I try to send, nothing happens. It simply says send 0.1 SOL here because this call gets commented. Simply the alert happens, but the real money never gets debited. The Phantom pop-up only didn't came. How will this be able to sign the transaction until Phantom pops up an approval? So if I comment this now, and now if I try to send, you will see alert did not come. First a pop-up came. User can approve or deny. If the user approves, then the alert will come. Okay, 0.1 SOL has been sent. And if you look at the balance, it will be down by 0.1 SOL now. It's down to 0.0758 SOL. Cool. That is how you can create a send transaction function. And this is super important because when we get to the token launchpad next, in the next video, we're going to get into the token launchpad. Over there, everything will look the same, but these transaction objects, which will become very complicated. What all instructions we send over here will get very complicated in the next video. But under the hood, we'll still be doing something like this, creating a transaction object, adding some instructions to it, and asking for approval from a wallet. Only the instructions would become things like creating a token mint or minting some tokens to a wallet, so on and so forth. Cool. That is how we do the third video over here, which is send a transaction on the blockchain. The last thing that is left is signing a message on the blockchain. Now, this is a very specific use case that is very important as an interview question as well. So let me just go to the next section now and share why do you need the user to sign a message and how can you pop up Phantom to make the user sign a message. Let's get into that next. All right. Let me introduce a new very special and specific use case to you. Let's say you create your own dApp today. And one famous one that exists on Solana is called Tensor, which is why I'm using their example because they have a very similar architecture. Tensor is a platform where you can come and buy NFTs. Now, what is an NFT is a different question for another day. But what does Tensor let you do? Tensor lets you buy NFTs. You go to tensor.com. It will show you a bunch of NFTs. You can click on buy. It will pop up a wallet. You approve. That NFT gets credited into your wallet or your address. So that is what Tensor is. And most of the time, when you go to tensor.com, you are interacting with the blockchain, or more specifically, an RPC URL of the blockchain. Now it could be DevNet, it could be Mainnet, but most of the times on a production website of Tensor, you are interacting with the mainnet blockchain. What are you interacting with? You are interacting with an RPC URL that is forwarding your requests. Things like what all NFTs does the user want to buy? And if you want to buy, you sign a transaction, forward it to the RPC URL. But what if you want to do something a little bit extra? One very common thing that dApps like Tensor have is something called the reward program. I repeat, a lot of websites, not just Tensor, have this thing called the reward program, which says कि यार जितना ज़्यादा आप ट्रेड करोगे, the more you trade, the more you buy NFTs, the more you put NFTs on an order book. Don't worry about what this last statement means. The more trading you do over here, the more points you will have. But these points are not stored on the blockchain. They are actually stored in some database somewhere. I repeat, as you interact more and more with the blockchain, somehow, the Tensor Web 2 system, the Tensor Web 2 backend, a simple Node.js backend, is listening on the blockchain and putting in their centralized database कि हाँ भाई Harkirat has bought 5 NFTs in the last 1 month. So we should give him, let's say, 100 points, something like this. So a lot of dApps that you will see will also have a Web 2 system where they will be storing things like the points that a specific address has. Why not store it on chain? Because it's just expensive to store on chain. It's, a reward program point that only matters for some time. Doesn't make sense to keep updating it so much on the blockchain. Anytime you buy an NFT from here, let's say plus 5 points happen in this centralized database, a Postgres database, a MongoDB database. So this database now has the total points for every user. The database looks something like this, that user 1 has 100 SOL or 100 points, and user 2 has 200 points, so on and so forth, where these users are nothing but public keys. They are just addresses of various users and how much points they have in this, specific on this Tensor website or, in this centralized system, let's say. So question is, when I come to this website, how can I get back my points? I can't talk to the blockchain. When I want to see my balance, let's say it shows me my balance here. I talk to the blockchain, I get back how much Solana I have. But when I want to get back my points, they don't exist on the blockchain. They exist in some database over here. So to get back how many points I have, be it 100 points or 200 points, I need to interact with a Node.js server. I need to send an HTTP request to, let's say, api.tensor.com. And I need to tell it, hey, this is my public key. And then this request will check in the database how much money you have, how much points you have. Return you how many points you have. So hopefully until now the problem statement is clear. Okay. Along with interacting with the blockchain, most websites have some centralized Web 2 backend. When I say centralized Web 2 backend, I simply mean a Node.js HTTP server. Think of this like an Express server, nothing too complicated. A Node.js HTTP server where when you send a request, it returns you things like, how much points you have. And if you have interacted a lot with the blockchain on Tensor, then you will have a lot of points. If you haven't interacted much, you will have less number of points. The question is, how does Tensor protect this specific database? How does Tensor make sure कि यार जब कोई मांग रहा है, when someone is asking for the points, how can they make sure that the person who is asking for the points indeed owns this public key? Person will send an HTTP request. Request will look something like, api.tensor.com question mark slash points question mark public key equal to whatever the public key is. So user will come on the website, send this request. The server needs to ensure कि यार जो भी request भेज रहा है, whoever is sending the request, ये public key उन्हीं की है. They haven't tampered with the public key. They haven't changed this public key to get someone else's points. The server needs to validate कि यार ये जो बंदा points मांग रहा है ना, the person who's asking for the points of this specific public key, they indeed own this public key. think of this like a centralized backend, a simple, let's say HDFC Bank website. If this is the HDFC Bank website and this is a client, whenever they ask, hey, how much balance do I have? The HDFC website needs to return, let's say 200 rupees, but it first needs to validate, is this person correct? This is where, if you remember, JWTs come into the picture. We've discussed this in the Web2 cohort. Cookies was something I talked about. They also come into the picture here. So whenever you send a request, you send your token along with it. You send something along with it that the backend uses to validate that this exactly is user 1, this is user 2, and returns, checks the database, gets their balance and returns it to the user. We want something similar here. We want whenever you ask for the number of points on this Web2 system, how many points do I have? You need to send something extra. You can't simply say, give me the points of this specific address. No. You need to give it something extra. I am this public key. I indeed own this public key. And now give me my points. You need to give it something extra. I want the points of this public key. And here is some message, some payload, something proving कि ये जो public key है मेरी ही है. I indeed own this wallet. How can you do that? And the answer is by using something called signing messages. If you remember, initially we discussed things like, when we were discussing the public-private key pair, what did we discuss? When we discussed public-private cryptography, we said if there is a message, for example, a message like this, login to Tensor. If there is a message like this, then if I sign this message using my private key, some gibberish will come out. And whoever decodes this gibberish using my public key, can indeed confirm that this message was actually signed by my private key. That is exactly what public key cryptography was. What was public key cryptography? You can generate a public-private key pair, and whenever you sign a message, let's say the messages could be anything, could be hello world, or let's say in this case is login to Tensor, then you can sign this message and send this signed message to anyone in the world, and they will be able to decode कि हाँ यार ये जो public key है ना, as soon as I sent this message using this public key, I was able to verify कि हाँ login to Tensor came back, or let's say I was able to convert this to the original message of login to Tensor. So I can verify that this message was indeed signed by this private key. If one person signed the message using the private key, if I try to decode it using their public key, I will get back their original text, or I can verify that this text was indeed signed by the private key corresponding to this public key. Basically, this is how terrorists, a very bad example, but this is how terrorists can send a message to the world, and you can be sure कि हाँ ये तो Osama से ही आया है. This came from, let's say, a specific terrorist. Let's say you are a terrorist. So what you can do is, सबसे पहले तो you can let everyone know कि this is my public key. My public key is whatever, something like this. This is my public key. Now after 5 years, if a message comes out that looks like this, kill people in country XYZ on 2nd Jan, if a message like this comes out, no one knows who sent this message. You can't be sure this came from the terrorist group unless the terrorist group used the corresponding private key of this public key. The terrorist group is the only one that have this private key. So if the terrorist group signs this message also, this is our message, and yellow there is the corresponding signature, then any news channel can decode this message using the public key. They can verify कि हाँ यार, if you take the terrorist's public key, then indeed the original message is verified. So this means this message came from the terrorist. So to recap, if you are ever, if you want to ever get lost, do one thing: publicize your public key. Publicize to everyone that this wallet is owned by me. For example, I can tell you everyone currently on this call, this specific wallet is owned by me, whatever this public key is, 7U89, the whole public key, this is owned by me. So if in the future, let's say I get lost, and after 10 years, you find a message that can be decoded by this public key, it means it came from me because I signed it using my private key, which only I have. No one else has my private key, right? It is in this browser somewhere in Phantom. I haven't shown it to you. So whatever message I sign using my private key, you can verify in the future with my public key and indeed confirm that this came from Harkirath. Similar example applies to, this specific example here. If a terrorist has publicized their public key, then whenever they sign a message using their private key, you can always verify using their public key that the source of this message is the terrorists only, no place else it came from. And similarly, if this is a Web2 backend, if you remember the original example, the example was that we have a Web2 backend system which needs to verify. We have a Web2 backend system where a request is going to come and we need to verify the public key is owned by a person. So we can just ask them, whenever you are sending this request, also sign a message so that we know that you are the person who is sending this key. So whenever someone is sending a request to get the balance of a specific public key, they also need to send across a signature. Hey, this specific, public key is indeed owned by me. And this is exactly what happens when you go to Tensor. If I go to this dApp called Tensor, which is an NFT marketplace. Harkirath, what is an NFT marketplace? There you go. Lads are pumping, baby. This is an NFT marketplace where you can come and buy NFTs. If I click on the buy button, a pop-up will come up and I can buy an NFT. But it also has a rewards section. If I click on connect wallet, select Phantom over here and connect, it has a rewards section which stores my reward points on a centralized server. So if I open this section, you will notice it says to view your rewards, you need to be authenticated. I need to authenticate first. Click on the verify wallet button. And when I click on this, what does it say? It doesn't ask me to sign a transaction. It asks me to sign a message. Authenticating wallet this by signing the message below, and it has some random hash that it returns me from the server. If I click on confirm, then I am using my private key to sign this plain text message. I am not signing a transaction. I am signing a plain text message, just like a terrorist might sign a message that says, bomb is going to happen in XYZ place. Similarly, I am signing a message. Okay, hey, I authenticate this wallet by signing the message below. And this message is somehow, in their backend stored, okay, whatever. This is, let's say, Harkirath's key or, this wallet's key, whatever. We can dive deeper into why it looks like this and why isn't as simple as login to Tensor. You can also have a simpler message over here like login to Tensor. Only problem is, that can be reused, which is why, you try to put a random hash here every time. Either way, now when I click on confirm, it will send a request to the backend with my signature. And now, as you can see, it is showing me my points, which of course I have 0 points right now. But unranked means I have 0 points. But if I connect a wallet where I've done a lot of trading using my Phantom wallet, let's say, then in that case you will see a bunch of points here. Cool. So what is happening over here? It would have been nice if I could have just shown you the network request. So let me try to do that. Let me connect a separate wallet. Let me change the wallet over here to account 7. Let me connect Phantom. And now, after I've connected, if I go to the reward section, it will again ask me to authenticate. Up to I have changed my wallet, right? I have connected using a different wallet. So let me click on inspect and inspect the network tab as I authenticate. I'm going to inspect the network tab and see what all requests go out. If I click on authenticate, requests go out. If I click on authenticate, verify wallet, a request goes out to a GraphQL server, which most probably returns me this hash. As you can see, it returns me this message to sign. What does it say? Get a message to sign, authenticate wallet. The Web2 backend returned me कि अच्छा ये बंदा login करना चाह रहा है. This person is trying to login करना चाह रहा है. This person is trying to login. Make them sign this message. And then Phantom popped up and made me sign that specific message. Then it sends another request to a GraphQL server, which is, trying to log me in. So if I look at the payload here, user profile, and if you look at the variables, this is my wallet and this is the signature. This is my signed message that I sent to the backend. So the backend was able to know कि अच्छा log Harkirat in. And once I am logged in, then I can ask for my points. It just stores this, whatever, most probably some sort of a cookie, JWT in my local storage. And then using this JWT, I can, do whatever. If I go back and show you what this JWT looks like on then it'll probably have my public key encoded somewhere. Yeah, it says profile ID, this is probably my ID in their centralized backend. So what have I done over here? I have created my profile on their server by passing in a signature, by telling them that this is me and this is my signature proving to you that this is me. Please create a profile on, Tensor ka Node.js server so that, you can start to track my points and, store how much trading am I doing. So that is why signing messages is an important use case, specifically when you are interacting with Web2 backends. When you are interacting with Web2, Golang, Node.js, Rust, whatever servers, in this case, you ask the user to sign a message. The question is, how can you do that? How did Tensor pop up Phantom over here to sign a message? Which thankfully is fairly simple. If you look at the sign message.jsx component now, the last component for today, this one, ignore the imports. I've added 2 new imports here, a base 58 import and a ed25519 import from @noble/curves/ed25519. We have seen this in the past. This is an implementation of the ed25519 curve. This is a library that lets you convert, let's say, a string to base 58 or base 58 back to text. And over here in the sign message component, I ask the user, write whatever message you want over here. Of course, if this was something like Tensor, then I would have an automated message, sign into Tensor, or something like that. But here, I ask the user, jo message likhna likh. You want to write hello world, you write hello world. You want to write terrorist attack somewhere, you write that over here in this input box. And then when the user clicks on the button, I first check, does that public key exist? Are they connected? If not, throw an error. Is sign message a function, which will be a function if the wallet is connected? So, ignore these 2 checks if you want for now. Here, I get the message, whatever message the user had put in this input box, I get it in plain text over here. I encode the message into bytes. What is this new text encoder? It lets you convert a string into bytes. The browser does not have this concept of uint8 array, if you remember. If I open my browser, it actually does. It doesn't have the concept of, it does. It doesn't have the concept of a buffer. It does have the concept of a uint8 array. It does have the concept of a uint8 array. I can probably convert this into a uint8 array also. That is also fine. This also does the same thing. Let me show you. If I do encoder.message or .encode, let's say Harkirat, it will convert Harkirat into a uint8 array. That is exactly what we wanted, right? We want to convert this into an array of bytes. And once I've converted my message into an array of bytes, I can call const signature equal to await sign message, which comes from where? It also comes from the use wallet hooks. I want to pop up for Phantom to make the user sign a message. What is the contents of that message? This encoded message right here. Where does this come from? This comes from this message variable. Where does this come from? This comes from this input box. So this will pop up Phantom to actually, show them nature over here. And ideally you should send this to your Web2 backend. You will send this request to the Web2 backend. You will send this signature to the Web2 backend. And this public key belongs to you. But here, just to keep things simple, I verify over here whether or not this message signature is correct. So in the real world, if you are creating something like Tensor, this check would happen on the backend. Whenever the user, if you remember, a request on the backend with the signature, on the backend, this verification would have happened. Abhi, just to show you guys, the signature can indeed be verified using this message and the public key. What are we checking over here? Is this signature valid for this message on this public key? क्या ये message इस public key के corresponding जो private key थी उससे आया था? Did this message get signed by the public key of the corresponding, or by the private key whose corresponding public key is this? Did this message get signed by the public key by the private key whose public key is this. I will repeat. Did this encoded message get signed? Did this signature get signed when this encoded message was signed by a private key whose corresponding public key is this? That is what this check does. What does it do? ed25519.verify. Verify, okay, is this signature correct for this message on this public key? Which means, was this signature done by the private key whose corresponding public key is this? I will repeat. Was this signature done by the private key whose corresponding public key is this? What does this sign message do? It pops up Phantom. What happens in Phantom? I sign the message using my private key. And here we verify the same thing. If the verification doesn't succeed, then we should alert something like message is invalid. If it does succeed, then we say message is correct. Let's try it out. Let me copy this code. Create a new component over here called sign message. Paste the whole thing here. Go back to app.jsx. Comment send tokens and include sign message. And now if I go, I don't know if I've added this library. I probably need to do that. npm install @noble/curves. I think that should do it. npm run dev. I don't think if I've introduced base 58. Let's see. Message is going to be hi there, let's say, and click on sign message. It pops up backpack in this case because backpack is connected. What does backpack tell me? Kyar approve Solana message signing. Do you want to sign this message? Let's say I click on approve. It says success. What does that mean? What does alert success mean? It means, okay, control reached here. It did not throw an error over here, which means the signature was indeed correct. I can also, it is already logged. Let's look at the signature. If I click on inspect, go to the console. I don't see the signature. Let's try it one more time. Approve, alert. Oh, I alerted it. I did not. Console.log. Oh, you'll probably see it in the alert then. Sign message, approve, alert. It does only say success. Let me log this second thing, console.log. And now let's try that one more time. Sign message, hi there. It says message signature is this. This signature, if I broadcast to the world, then the world would know, okay, this hi there message was signed by Harkirat, whose public key is this, and whose private key, of course, is stored somewhere in this wallet. Since my private key is stored in this wallet, I need to, pop up Phantom, and Phantom needs to approve this message. When I click on approve is when the private key signs this message, is when this signature is created. Cool. That is what the fourth thing for today was. If you go back to the 4 use cases we were supposed to build today, we have now built a request airdrop component, a show Solana balances component, a send transaction component, and a sign a message component. Why is this used usually? To verify the ownership of a wallet in a Web2 backend. That is the reason why you use, message signing from time to time. That is it. I'm going to put my video in here. It's fine either way. You guys don't need to see my face. In the next video, I'm going to cover, if I go back to the beginning of the slides, this is what we were supposed to cover today. So we have covered point 1, 2, and 3. The thing that is left, this was done in week 6. So in the next video, I'm going to take you through how can you create your own token launchpad in React, which is again a dApp, but a slightly more complicated dApp. And it would require you to dig into a bunch of Solana libraries, which is why it is a slightly harder app compared to what we have built until now. Cool. With that, let's end it. I will see you guys in the next one. Bye bye.